Hey everybody, this is Larry. This is day 11 of the Leetcode May Challenge. Let's get to it. Hit the like button, hit the subscribe button. Let me know what you think about today's problem, what strategies you took, and that's how it goes. Foot fill, okay. Foot fill. An image is represented by a 2D array of integers, each integer representing the pixel value of the image from 0 to 65,000. Given a coordinate SRSC representing the starting pixel, row, and column of the foot fill, and a pixel value new color, foot fill the image. To perform a foot fill containing the starting pixel plus any pixel connected forward directionally to the starting pixel of the same color as the starting pixel, plus any pixels connected forward directionally to those pixels, and so forth. Replace the colors of all the aforementioned pixels with a new color. At the end, return the modified image. Okay, this seems pretty straightforward. So there are a couple of ways to do this. You could do it with breadth first search. You could do it with depth first search. This is pretty standard, and I would recommend it on interviews for studying for interviews. That is because these things come up a lot, as far as I know, and you're probably going to get asked both ways, both recursively and iteratively with a stack or a queue. Let's see. The end will be from 250. That's fine. The starting pixel will be within. The value of the color will be between 0 to 65K. The only thing that I have to make sure that I understand what the answer is if you try to change the starting pixel color and it already is the same color, that's the only case that I wonder what the answer should be. So let me start by doing a little bit of a TTD paradigm by just return an empty list. And I just want to see what they expect. And here, unlike a contest, I get to do it. And of course, in an interview, just ask your interviewer what they expect. Okay, so basically change nothing if it already is that color. Okay, let's do it then. So I'm a I'm just thinking about doing it by first search or depth first search. Either way is fine by me. So I'm gonna do it with depth first search, say, and then let's get to it. Then, given that this is an image of list to list, so we could actually do this automatically. So let's just have a fill function, a current x and a current y. So maybe rows and columns would be better, but and I think that's pretty much all I need. You could say that I could put in a few more things depending on how I want to handle it, but I'm going to use a little bit scope to handle some of it, like not needing to know new color, for example. Let's call it because I keep on forgetting in the past, and then let's return image. So there are a couple of ways we can think about what we want to do. I'm doing it in place. These are things that you would talk about with your interviewer about, well, do I need to do it in place? Should I make another copy? What is the expected behavior, right? For me, foot fill makes sense as a function that manipulates and mutates in place. It doesn't have to be, but for me, that's how I would talk about it without my interviewer. But whether it doesn't matter which way you go, but you just have to be able to talk about it, the whys and the trade-offs. And in this case, it's probably like a product E engineering decision in either case. So yeah, so let's say if image of CXCY is already a new color, then we could return because this is done. My job here is done. Otherwise, so I'm going to cache this so that we don't keep on generating, but I'm just going to have a list of deltas for the X direction and the Y direction. And now we just do for dx, dy in directions. I use this notation where I just go in new x is equal to cx plus dx. and also cy plus dy is uni, right? And then if 0 is between, sorry, nx is between 0 and, oh, they don't tell you the, okay. So we just have to set it up. So rows is equal to length of image. Columns is equal to length of image of 0. Notice that, okay, I just wanted to check whether it could be 0, but because they're both at least 1, so I don't have to gate this. But okay, so then now nx is 0, and same for y. Fill cxcy. We should probably change the color because we didn't do that. And that's pretty much all I have to do, I think. So let's run it real quick. Looks okay. Maybe because I put in the wrong function, the wrong recursion thing. That's why you always check answers, but this looks okay. Oh, maybe I misunderstood the problem a little bit because now I flood fill everything, which I guess happens. So we only want to flood fill with the same color. Okay, so then, but that also shows that if you have a good structure around your code, it's really easy to add. So now we just have to do old color. Because that's the color that we want to change from. So now what's our base case? So now we check, well, if image is not old color, return, because if it's not the old color, then you don't change it. Okay, so, and that's all we have to, well, okay. We have to change this too, but that's fine. And we could actually just set it outside just like we did with the new color. It's outside the function, but should be okay. Okay, so now we also show a little bit of a quick debug and how if you have the right idea, if you have the right algorithm, even if you have minor changes to, you know, what you thought the problem was, like I did, I forgot actually about the part about the previous color. Whoops, I just fought everything. But yeah, but once you have a good structure about how you think about the code, then changing it is just pretty easy. Okay, let's submit this before I keep on saying how easy it is. Okay, cool. So it did get accepted, so I don't have to feel sad about it. But yeah, so this is depth first search. The way I implement this is just for each pixel, we look at the up, down, left, right, and then just process that pixel. You can also do this with breadth first search with a queue, and it would pretty much roughly be the same thing. So now let's go over what is the complexity, right? Well, we look at each cell once, and each cell branch out 4 times. I say branch out, but that's probably a wrong terminology. But each one of these does 4 operations. So the answer is going to be n times m, or rows times columns. O of rows times columns is the time complexity. For space complexity, it depends on how you want to talk about it. Again, because I did this in place, you could make an argument that's all 1 extra space, but that really depends on what you intend the function to do. Because in either case, it's going to be your lower bound. And what I mean by that is, let's say you have to create a new image, then it's going to be all of rows times columns as well. But for space, but that is your intended. I mean, that's your lower bound for that solution anyway, because you have two different ideas of what you want to do with the function. In this case, I chose to implement the one with in place, but you have to analyze what you're given and the product or the product decisions that are made that for this problem and for these problems in general. So yeah, as I mentioned again, definitely practice problems like this. It comes up all the time, depth first search, breadth first search on interviews, and competitive programming in general. Let's take a look at the hint for fun, where the recursive function. Okay, that's what we did. So yeah, that's all I have for this problem. Yeah, let me know what you think, what you did. Did you do it with depth first search or breadth first search, or did you do it with another funky way? Let me know, and hit the like button, hit the subscribe button, and I will see you tomorrow. Bye-bye.